Who am I? I'm Brian Clarkson, a professor at the University of Michigan in the Department of Karyology, Restorative Sciences and Endodontics, of which I was the chair for 14 years. What am I? I am a dentist, qualified at the Leeds University Dental Institute, UK. I then came to the States and completed a master's degree at the Eastman Dental Center in Rochester, New York, in karyology, after which I became a flying dentist in northern Queensland, Australia. A lot of stories about that, but on another day. I then returned to the UK to complete a PhD at the University of London. For over 40 years, I have been involved in the discipline of karyology as a practicing dentist, an educator, and a scientist. I have seen the discipline evolve from one where you could tell the age of a child, I am a pediatric dentist, by counting the number of carious teeth, to today, where the discipline's goal is non-invasive dentistry. We know how to prevent, treat, and slow, even reverse the progression of caries. But one thing we had not attained was an easy, visual, inexpensive, and reliable way of distinguishing between active and inactive early carious lesions. As I say, the holy grail of karyology. Because if we could do that, then we could focus our treatments on the teeth that had active disease to halt its progression before cavitation occurred. Using my experience as a clinician and researching the literature, I found studies reporting that an active white spot lesion had a rough surface, a white appearance when dehydrated, and the lesions occurred at sites where a pathogenic plaque could accumulate. Studies in the 70s and 80s had shown that the surface of white spot lesions in enamel was slightly demineralized, but the subsurface could be as much as 30 to 40% demineralized. Could this lesion porosity be used to detect early carious lesions in enamel? Along with two dental students, we scanned the surface of caries-like lesions produced in the laboratory using atomic pores microscopy and discovered pores in the surface of these white spot lesions ranging from 10 to 600 nanometers in diameter. To help in the detection of the lesions, I treated the surfaces with vegetable stains and food dyes, which appeared to identify the lesions, but were easily washed out and also stained non-carious surfaces of the teeth. Serendipity. At this time, I was introduced to Jorg Lahan, a professor in the Department of Chemical Engineering at the University of Michigan, who is a world expert in nanotechnology. I told him about my research, and he told me about nanostarch particles, which a PhD graduate student was using in his lab. I was immediately interested, as these would be biocompatible, non-toxic, and biodegradable over time in the mouth because of the amylase in saliva. Not only that, he told me that the particles could be tagged with fluorescein, which would light up under a certain wavelength of blue light. Bingo! We tried the tagged nanostarch particles on the artificial lesions, shone the composite curing light on the lesions, and they lit up like a Christmas tree. Even better, when we remineralized the lesions and applied the particles to the lesion, shone the light, they did not light up, So now a dentist or hygienist had a way of detecting early carious lesions in enamel, focusing the treatment to prevent the lesion cavitation and monitoring the success of the treatment by reusing the nano-starch technology. But the nanoparticles technology needed further development, and the graduate student, now Dr. Nathan Jones, will take up the story.
Thank you, Brian. So I've been working with Stephen on various applications and targeting concepts involving starch nanoparticles since 2009. After finishing my undergraduate degree at the University of Waterloo in nanotechnology engineering and following successful work terms with Ecosynthetics working on industrial applications of starch nanoparticles, I was eager to begin my graduate studies at the University of Michigan in polymer engineering, a chance to explore the potential for using starch nanoparticles for medical applications. I was impressed by the highly impactful research of Professor Jörg Lahan and joined his research group. I remember one day being called into a meeting with Jörg and Brian and talking about the idea of taking these starch particles that I was working on and modifying them to be able to target dental caries. I was very excited when one of our first formulations illuminated the carious lesions with a very bright and clear fluorescence. And I knew we were onto something big when I saw how the particles were targeting the entire subsurface porosity of the caries when viewed underneath the microscope. With this proof of concept, I reached out to Stephen and Wendy and shared the results at Thanksgiving dinner in 2015. Shortly thereafter, GreenMark was founded, and it was a big honor to be recognized early on by the International Association for Dental Research in 2016, South Korea, with the Top Cariology Research Group Award, as well as the Colgate Research and Prevention Award at the international meeting. I've also really enjoyed the entrepreneurial aspects of building a new company together, involving world-class collaborators in an environment that values innovative research and development. We have many other product development concepts in our pipeline, and that keeps my job fun and exciting. Into the future, I'm looking forward to sharing our progress in these areas with the many oral healthcare professionals that are looking to do what is best for their patients.
Well, hello, my name is Wendy Bloombergen. I'm actually a physician trained in internal medicine and kidney disease. After a time working as a member of the Faculty of Medicine at the University of Michigan and raising my children, I was ready for something new and possibly entrepreneurial. And that happened to be around the same time that Nathan, who you just heard from, helped invent this new starch nanoparticle technology. Now, Nathan was a family friend, and I distinctly remember the day he joined us for Thanksgiving dinner and showed us photos of starch nanoparticles illuminating demineralized areas of tooth enamel, early tooth decay. I believe it was actually that day that I decided to help commercialize this technology, and my second career began. Now, even though I was a doctor, I knew nothing about teeth. We learned very little about teeth in medical school. So I began literature searches and attending dental meetings. What I learned early on was that dental caries is the most prevalent chronic disease in the world. 96% of Americans develop tooth decay in their lifetime. But then I was astounded to learn that it's the only disease that has been primarily treated with composites and metals for more than a century. And that despite scientific literature over the past 20 years, indicating that the early detection of caries should allow conservative treatment of carious lesions, dentists have not widely adopted conservative management strategies because they lack the tools to do so. If there were better ways to detect, treat, and monitor the success of non-invasive treatments, the benefit would be preservation of precious enamel and improved oral health outcomes. And that realization has turned this project into a passion for me to help preserve teeth through earlier caries diagnosis and non-invasive treatment. This has been incredibly challenging at times. For example, raising money to fund the project was especially difficult and took a lot longer than we expected. Our big break, I think, was when we received an NIH grant. That was validation that this was real and that other scientists, reviewers ranked it high enough to receive NIH funds. And that then led to subsequent funding from investors and additional NIH grants. There have certainly been other challenges, but also wonderful accolades, such as winning a Cellerant Best of Class Award. All the while, we forged on as we are resolute in our mission. My official title at GreenMark is VP of Clinical Affairs, but like all of us, I wear many hats in our startup, helping with product development, grant writing, regulatory efforts, and planning clinical research, all the while providing a general medical presence. Now I'm now going to pass the baton over to Stephen Bloombergen, CEO of GreenMark, and also my husband, who will tell you more about GreenMark's founding and mission.
Thanks, Wendy, and thank you for visiting us. So my passions include nature, biomaterials, and nanotechnology. I've spent over 30 years developing biomaterials products and have 20 years of expertise and business success with starch nanoparticle products. Yes, you must be wondering, well, I finished my PhD at age 9. So GreenMark was founded in 2016 to develop and commercialize targeted medical and dental products. I learned that more than $200 billion are spent globally on dental caries and its complications. At GreenMark, we believe status quo is not an option, and we're taking advantage of both biomaterials and nanotechnology. In fact, human enamel itself is a beautiful example of this. It consists of rod-like structures reminiscent of a Greek temple with its tiny pillars stacked closely together. It's the hardest surface in the human body. Then when plaque forms to a smaller or greater extent, depending on oral hygiene and other factors, and we eat sugary foods, the bacteria in our mouths have a feast, shed out organic acids, and the caries process begins, creating surface and subsurface porosities in our enamel, as Brian just explained. So typically, by the time we find it, it's already a cavity. Wouldn't it be far better for all of us to find caries early and treat it non-surgically while we still can? At GreenMark, we are focused on helping dental professionals preserve teeth through earlier diagnosis and non-invasive treatment. We have a technology platform in which we transform native starch into nanoparticles and then attach functionalities so they can be targeted and go exactly where they're needed. We can target and eliminate early stage caries, and we're also working on a treatment where we can load fluoride as well as the essential minerals depleted as a result of caries right inside our nanoparticles, and then target their delivery to the enamel subsurface so the lesions are filled in a much more natural way. So we're aiming to redefine caries control and prevention by eliminating ambiguities in early detection and improving patient engagement. This can help your clinic grow and increase clinic revenue while improving oral health outcomes. So we look forward to working with you. Please visit us at greenmark.bio as we eagerly await clearance for our first product, the first of many that we plan to bring to you over the coming years. Meanwhile, from all of us at GreenMark, all the best to you and yours during these challenging times. And thank you for visiting our booth.
Goodbye, everybody.
Bye-bye.